I'm going to go from my immediate left. I've got Adnan Hamid, who is the CTO of Breker, and I think something else as well. President? Yes, President as well. Then we have Michael Chin, Senior Principal Engineer at Intel. We got Deepak Manoharan, who's Senior Director of Engineering at ARM. And on my far left, we have Shelley Henry, who is CEO of Moore's Lab AI. So good cross-section of both AI, all AI verification and users of a combination of those two things. So I'm going to ask an opening question for these guys. Why do we need to automate spec-driven verification? That's the topic of this panel, spec-driven verification. Why does it need to be automated? What's wrong with the DD team just reading the specs and writing their own tests? So I'll start with you, Edmund.
Yeah, sure.
Okay. Well, okay, I'll start with Michael.
Actually, I see.
Oh, come on, guys, don't do this.
Manager. Oh, exactly. I can probably start. The whole reason which comes to my mind is we hardly get good specs. Specs keep changing all the time. And we read the spec, we get a spec and we write a specification, and when the spec changes, again, reviewing, tracking, and keeping up with that is always a challenge. So if we can rely on AI tools or automated methods to keep track of it, and by doing that, productivity will surely improve, and we can also reduce any human errors. Those are the things that come to mind.
Can you think of any particular examples? I mean, not revealing anything proprietary, but something that springs to your mind of, man, if only we'd been able to automate this, what would that have looked like? What was that problem?
One of the things that comes to my mind is test plan, right? Like especially for verification, a good test plan is extremely important. And now if a feature was missed in the architecture or microarchitecture detail was missed, and if the architecture and the design teams have forgot, or for whatever reasons, or even for real reasons, specifying that in the specification, the test plan is not going to have that information under the test, and we are going to miss a bug, right? So this happens on a regular basis because most of the designs, you don't really take a well-established specification to be development. We are crossing the bridge,
as you're building the bridge.
As you're building it. So that's always a challenge. So having AI or any kind of tools, as your friend, as your, as a co-pilot, as somebody who can really work alongside you, guide you, help you look at blind spots, and reduce the time that it takes to iterate and get to the real bug, it's always a wonderful value. That's what we have seen from time to time.
Okay. Michael, now you can't pass the buck again.
No, you can't pass. No, I think it comes back down to time and quality, right? You have schedule pressure, you have quality pressure, you don't want to escape any bugs. From the technical perspective, it drives me insane trying to think of how do I get my engineers, my team, to continue to stay on top of all of this ever-changing landscape, right? And the technical challenge is very great. So AI tools, because we have capabilities that we have agents that can go do work for you, you have self-learning techniques it can self-improve, those provide potential for us to be able to say, okay, we can design something once, and if we design it correctly, it will help us to get into a space where we don't have to have as much constant pressure on us. We're in a human resource crunched environment, so now the pressure can hopefully start to lower on the people.
So that's great. Thanks, Michael. That's a good general answer, but can you think of something that you're allowed to tell us that would be sufficiently anonymized that you could say, this is one particular example that springs to mind?
I think in the validation space and verification space, it is the complexity of the problem. So I'll just speak to like previous Intel around where they were saying, don't do this with our controller because if you hit this condition and this condition, bad things will happen. And why did we have to issue an errata like that? Because somebody forgot to take a look at the spec and say, oh, for this domain and the secondary domain, when they work together, they don't work very well together. And so we didn't test sufficiently, right? AI can help us to be a safety net because it can look at everything with equal weightage and say, okay, maybe you need to take a look at this domain and this other domain, take the third domain, cross them all together in order to figure out, and this is where there's the risk, and we need to go examine that.
Good. So Shelley, you're lately of Microsoft, so you must have these experiences too.
Yes, I did. It was back in 2015. I was asked to, or me and my team were asked to do the verification for DDR controller. And the spec was probably around 600 pages. It took me literally 2 weeks to read through the spec, understand what it is, and come up with a test plan. This was after being in the industry for over 15 years.
Only? Only 2 weeks?
So, out of that, like, after reading through 600 pages of spec, probably only 50 pages were actually relevant to what I was doing. So I spent all this time without any, which could have been used in better ways. So I think that's where AI comes in. That you get to the relevant portion very quickly. So yes, if you don't read the spec, yes, you're missing out on how the protocol works and all other things. But there's a better way of doing this, at least in my mind. You ask the questions to the knowledge base with the spec at the back and understand the relevant portions of what you should be focusing on, not the version history and the overview and all the other kinds of jazz that the designer or the architect is doing. You still have to read for all that because you don't know what you're missing. But AI is going to parse through all that and give you the relevant issues that you need to be focusing on. That will cut down the time you spent on reading the spec.
Adnan, I know you got the question, but I also know you have a lot of experience in this area, particularly with respect to RISC-V specs. And I don't remember whether it was MMU related or whether it was multi-core and cache coherence related, but you've run into a particularly nasty problem.
All of them have. Yes, so I think the roll-up answer, right, of why do we want spec to verification? The definition of verification is proof that the implementation matches its intent. So what a beautiful idea, right? Just read the intent of the spec and prove that we've done the right thing. Surely we want this, surely we need to work towards this, and surely we're not there yet. Right? So let me pull some of the threads that already came out in this panel. So Deepak, you hit the nail on the head. We write incomplete specs. And every spec I read says it works just like generation N-1 except. Well, what did generation N-1 do? How much do we write that it is assumed that the reader understands how things work in general, and it's just explaining how things plug together. We need to solve these problems, but maybe we need to get good at getting these AI agents to go off and say, tell me what you made of the spec. Tell me what you think this thing does. right? Forget even writing tests or test benches or any of that. Just come up with more complete ways of expressing what this thing is supposed to do. And Bernard was referring to me, Vision, if I can say that, on a panel about how hard it is to read some of these specs, right? We do a lot of work with RISC-V, very concise spec. I have not yet been able to prove anything incorrect in the spec. But my goodness, you need to know a lot to make sense of it, right? So I think these are very hard problems, and I think we should break it down into smaller questions, namely, how do we even extract a complete specification from this partial word salad architecture that you give us? Many problems to be solved.
I'm going to drill a little further into this because I have to know more about this, thanks to you. So the one particularly challenging thing was the fence instruction, the definition of fence. And I believe, although I've never tried to read it myself, that there's a big chunk of the RISC-V spec that is dedicated to fence instructions and how they behave. And if you read that, you have a pretty comprehensive understanding of fence, but not a completely comprehensive understanding of fence, because there are other places in the spec where fence behaviors are sprinkled, where you have to understand that sometimes they slightly qualify how that instruction behaves. And if you don't understand those qualifications, then you can overlook something. Is that right?
Absolutely. So Bernard over here is poking my hot button. Yes. We ran something where we did some generating tests. Our tests just would not work. No matter what we tried, it would not work. And I'm not making any sense of this. And eventually, after much work, it turned out there's half a sentence on page 41 interacted with half a sentence on page 97. And together they gave me this realization of something enormous that you had to do. Well, Doug's over there nodding away. To sort of realize that it works very differently than the way you think it does, right? So I think the RISC-V spec is an excellent counterexample of what's easy for AI to digest. I don't think it's AI's fault, by the way. I mean, it's just written in such a terse way that it's very difficult to understand, right? So yeah, these things are hard, and just a lot of specs. All of you are DV engineers, all of you have read specs. You just know that you're reading these words, and it assumes you know 40 years of history of how things are supposed to work. Well, I want to be able to pull that out all together for us, but as yet it seems not to always. So,
Sorry, no, I have a question for you.
You have better.
Have you tried using AI to ingest that spec?
We have done this massively and systematically. We have found it incredibly productive in certain areas, totally lost in other areas. Personally, our experiences with getting AI to read a raw spec and generate just intermediate representations. So I'm talking about full table of opcodes or what opcodes could use what arguments, simple stuff, right? Yeah, not so much. It's 95% there, but the remaining 5% is bloody hard to find.
That's good insight. Thank you.
Have you characterized that? Is it a writing style problem, or is it some other problem?
Now, this is a great question. Why did it catch? Why did it get 95% of it and not 5% of it? I didn't have that insight.
Shall you?
I can't say for all AI systems, but there are techniques that at least we use that might help with this problem. I can't go into the details of the techniques for obvious reasons, but yes, I'd be interested to see like how we can solve that problem or how close. We might not get to 100%, but we might get very close.
So pretty good, but some hand carrying required.
I have one unique experience. Right? Hallucination is a very big problem when it comes to AI. AI never hardly says, I don't know. So there are times where it would fill in the blanks, right? And it would try to really put the pieces together.
and especially, on the techniques, right? I think we have to, constantly give feedback to AI and not take whatever response is. This is what I have tried doing constantly, or I keep telling my team to do it, is don't take the first response as the right answer, right? You ask the same thing again, it's like
Give you a different answer.
right? And so you have to really go back and forth. And that actually happens. One example that I wanted to share, which was very good. You take a block diagram, right? You can take a picture, load it onto the AI, and then you can also pass in the specification along with it. And then it would really do a pattern matching and then say that, okay, for this block diagram, this is the microarchitectural specification. And then I also took the RTL or the design code, loaded that. And then I was just curious, right? Without even writing one line of code, can we really do a correlation from a block diagram to a specification to the RTO? Then I asked for this particular design, you have all the details. Tell me, do you really think it has been implemented, pretty much matching the spec as Adnan was actually mentioning? It actually did a very good job. It actually said that, okay, and I also then fed my test plan. It said that, okay, your test plan covers like 95, 94% or whatever, and then you should probably look into these areas. And then once you give a weightage, you can work with AI and you can, you can get to a problem guided problem area relatively faster. That was very, very helpful.
Good.
Yeah, I like that fact that what you mentioned, people, AI never tells you that, that is impossible. Which is very human to do. I think that's still the differentiating factor. Yeah,
I saw an Anthropic demo on firmware debug, and that point came up, and the little agents in the Anthropic demo were congratulating each other on how good of an answer they gave. And somebody's watching this and saying, "What the heck is going on here?"
But if I can, isn't that the problem though? Because it is so enthusiastic and so assertive in its correctness. Unless you know what's going on, you don't really know what was fun and what was actually correct. That's the big challenge that we face with this.
that is true. The kind of things that we do in AI, it's like, one is you ask multiple agents and multiple models and see like who gives what's the majority. That's one way of doing it. And then the other way is like having some kind of a critique agent, which is completely decoupled from the main agent, and say, given this input and this output, does this output infer from the input? Right. So those kind of techniques we use within our platform.
Isn't it also true that, there seems to be a trend towards let the AI agents do their thing, but not kind of continuously. You've got to jump in periodically. You've got to have checkpoints and say, okay, do I trust where it's going? Is it going down the wrong path?
Yeah. So that is the human in the loop philosophy. That's part of what our philosophy is.
Yeah.
And that's something that I've seen in implement tools too. When we let a hallucination happen super early on, it'll just go completely down the wrong path. So you have to figure out where in your AI design do you need to have some sort of a feedback, a critique, a judge LLM loop. So that way you can then figure out what is the right answer, and then you can continue to progress with more certainty. And also, I think those judge stages are very helpful because they allow for us to be able to provide feedback to the LLM. So the next time around, it can say, hey, don't make the same mistake again, right? And in that sense, I think an LLM is very human. It learns from its experiences.
That's a good point.
And I've seen the correctness of our LLMs go from like 40% on a given task and a given attempt. So now it's up to 100% because it's learned over successive tries what to look out for and what not to look out for.
Great.
Actually, what Michael said, reminded me of another interesting aspect. In my mind, AI should be seen as a team sport and not like a tennis match. The reason why I say that is, especially if the same ID or token is shared by a team, then every team member asks for information differently, prompts differently. It also helps AI to learn quicker. And then feedback mechanism improves and the accuracy also increases over time.
I don't know how that happens. Multiple human beings working on the same problem with the same AI engine. Is this your?
Yeah.
Oh, that's the opposite of what Shelley said, which is one human being querying out to multiple AI engines, right?
But both are important because in a team,
Many to many, good.
it's like that, right?
Yes.
Because especially you want to, because whatever comes to my mind, another person would have not thought about it. But now if you are training the same model, it helps the overall project goes better.
Good.
Sure, and I think what I'm about to say will dovetail exactly with what you guys are saying, which is I think of it as these machines are like little new grad engineers who will work very hard but know nothing. And you got to break a big task into small tasks where the output of each task is reviewable, unit testable. And once you got faith in the first piece, then start plugging into the subsystems and ninja systems and so on.
Yeah, it's like decomposition down to the bottom levels, and then you start building up once you've got trust in what the bottom levels do. Is that what you're saying?
And frankly, I will say, I find these things very useful for the decomposition exercise, right? Throw in some vague question, he gives you some vague answer, you go, that's wrong. So much easier for human beings to tell that's not the right answer. It's harder for us to build the right answer because that's not right.
Yeah.
So what wasn't clear enough in my specification, right? Go through this 6 or 7 times. Now I understand my question.
Good. So I think we need to move on to our next question. Great job, guys. So if we are going to build an identity verification system, then what are the necessary components in that? We talked it out a little bit, but what do we need to be able to have trust in that system? So anyone want to start on that one?
So the biggest thing, well, there are many components to the verification process that we can automate using AI. The underlying fact is like, how much do we trust these processes, right? So it's verification, if you make a mistake, it's a very costly mistake. So we cannot afford to do that. So it's not just like building software where you can easily write patch. We are looking at a respin which will cost tens of millions of dollars.
Mm-hmm.
So that's why companies spend a lot of time and effort in mining on verification. We should. There's no running silicon. So when we apply AI to that, we have to make sure that we still have the same kind of trust using our AI system. That has been our biggest challenge so far, to build that trust, that AI can be trusted in verification.
Mm-hmm.
How to build that trust it will come over time, I think, because right now we are still, a lot of us, including a lot of other startups as well, are experimenting to build that to a good extent. The biggest bottleneck here is there's no real benchmarks for this right now. So everyone is trying to come up with their own kind of benchmarks to say, like, hey, this is as good. We looked at it and it looks good.
Mm-hmm.
That's not going to be. At some point, we have to, in my mind at least, it has some kind of standards to say that this is good.
Well, I was thinking of some kind of concrete dates. So things like, of course, simulation, static analysis, formal analysis, linting. All of these things are kind of AI-free methods where you can say, I know if I run this and it does the right thing, then it's good. And if it doesn't do the right thing, then the AI messed up somehow. So I wanted you to talk about that.
I think some of these answers are possibly obvious, possibly why we're working together in the first place, right? All of us have probably had AI write us a Python program one time or the other. We never thought to ask it to build a binary for us directly, right? We asked it to write a Python program that then runs on a computer. Probably we will still use simulators, but probably still use emulators. So in theory, the output of AI could be 42, check. Yes, we're done, right? Nobody wants that, right? Nobody's gonna buy that at this point. So why Shirley and I working together in the first place, right? We are the back end to sell them. We know how to take these PSS models that generate tests for SoCs or IPs or simulation emulation post silicon. I think having these tools as your back end is a natural thing to do. So I think some of those basic tools will be there for sure. Then I'll throw something at Shelley and let them take over. The other thing that we need that I don't know that we necessarily have as humankind is what are clear ways of describing what aspects meant to say, right? This notion of get an LLM to go read our incomplete specs and make a complete spec that can be reviewed. How? I don't know, but flowcharts, something that is understandable and reviewable, right?
I would like to add one, probably a different aspect to it, right? Like the way I'm looking at AI, let's say if I'm going to adopt AI as a user or as a person who's responsible for taping out a chip, what is that I'm trying to do? Entry to barrier to entry should be made, yes, which means if I'm going to get an engineer to work on a program or a product, rather than starting from ground zero, can I really have AI help me start, let's say, from ground 40, right? So first, always building that bench, building that test plan, creating those first layers, and maturing that always takes time. So can I really, accelerate the time that it takes for me to reach that stability, right? So I'm being more conservative here. I'm not really looking for AI to completely, solve the magical problem, but I want AI to increase the pace at which I can get to my final destination. And more importantly, I don't want team members to be wasting time in iterating through cycles, which can be, which we can rely on AI actually.
Right.
Go ahead, Michael. To take your answer and also something Adnan said, right, we want to treat our AI as if they're just new grad engineers, right? My approach to do we trust AI is no, I don't trust AI. But what I do trust is I've set up monitoring, I've set up coverage, I've set up tried and true techniques that I force my AI to emit that information to. So I can review it and then continue to say, okay, you're just a really fast grad engineer, right? You can do all this work really, really fast, but you still give me the same measurable data points that I would expect from a human to do. And by that measure, then I can realize the efficiency, but also have something that I can review and show as proof.
And let me build on that, right? If we're good managers, we better not be trusting our engineers either, right? It's our job even with human beings. And I say this the best possible. You got to put counter checks for them to be able to figure out when they screwed up, right? I mean, this is what we do. So we say we trust them, we never trust them. But no, really,
Trust but verify.
yeah, trust right? That all of us want systems where folks who are working these problems can solve them and then know that really they got it right and screw it up. Right?
And if I may add, with the speed that AI can execute, it gives us an opportunity to go and say, well, we had this mountain of tests that we ran, we had this mountain of data that we gathered, right? Now we can spend more of that time to say, hey, is that data really doing everything that we wanted to do? All the stuff that we put into the bucket list of, we'll get to it when we have time. Now time's coming, right? And we can do a better, higher quality job because we have more bandwidth to address those problems.
Actually, to add to what you said, test grading is something that we used to do, used to spend a lot of time, but now I feel AI is a very good, can help there a lot. How can we get rid of the waste? And we can use the AI engine to do those analysis.
So that's a great comment. I wonder at what level you apply that, because you can trim out. You're talking about regression pruning, right? So you can trim out a lot of your regression tests, and then run regressions much faster. But there's always this concern of, did I overlook the one thing that something would have caught that I've now ditched because it's not in my list anymore?
I think that's the curse of being a verification engineer.
Yeah.
We will never trust. It's like that until the chip goes in the lab. But the thing is, I wanted to, let's say we're using Breker systems or any portable stimulus language. Most of the times what happens, they start with a smaller segment of a test scenario and they keep building on it. Over time, the one that they started with becomes redundant. But now we always have it in the database and everybody used to be running it part of the regression. It's like a waste of cycles and time, right? So now, recently I tried it was effective. You kind of load your complete test suite onto AI and say, okay, tell me if there is any kind of overlap or redundancy and what can be removed without losing the value, right? Those things can be done in a very simple way rather than us having to go and do multiple reviews and we invest a lot of people to do that. Those are the immediate value that we are getting right now.
So this is very interesting. Why would you just cover grade them? I mean, there are answers to this problem.
I'm just sharing an example of how we did that. That depends on. It depends on are you referring to portable stimulus or it's like
No, just doing coverage analysis across a suite of tests, figure out which ones are not finding anything different.
provided there is functional coverage.
Right, it's functional coverage.
Yes,
Okay.
that's what it is. At the SoC level, especially when you do system level verification, not every test will have a map. A functional coverage will not be mapped to a test case.
Oh, I
So
could
that's-
talk a year off about scenario coverage. but-
Yes, okay.
I would like to say something.
Okay,
I'm in trouble. I'm going to bring a surprise question, but not a difficult one on you guys. So we're talking about AI and PSS. What about AI and UVM? I mean, why is there a preference? Is it useful for both? Are both UVM and PSS viable targets for this?
It goes back to what Adnan said. We ask it to build Python. We don't ask it to build a binary. Right. There's a human readable aspect to portable stimulus that I really value, and I want to see AI engines also help me to realize. Because when an AI engine can create something that is abstracted and I can understand and read it in a matter of a minute or two, then it becomes easier for me to say, okay, you're doing the right thing. Whereas if I have to go through a UVM sequence and see every single command, the amount of load that puts on my brain, it's just too much.
So Shalik, why don't you say yes we can, and I'll tell you why we shouldn't.
Yes, we can. I mean,
That's true. It's what you're doing, right?
yes, in a way, yes. Because UVM is very popular platform that a lot of people are really using. So the biggest thing that I've seen, and it's with portable stimulus standard, is people are not willing to learn a new language, the new semantics and systems. They are hey, I don't want to learn the new thing, and then I do this, and then I use a tool, and then go do something else, and then I get my test case. I'd rather do my test case myself. So that is the mentality or the thinking. They don't really see the value of a comprehension of business. I think maybe because of various reasons, right? So they might not be familiar with this, or they're very familiar with UVM and the SQL, so they just want to do that. So if you take out the barrier of actually learning a new language, And if AI can do that, now you get the best of both worlds. That is what my thought is.
Thank you. Exactly. You're going to agree with the argument to not directly go to UVM is that we want whatever the IP guys are running to be pre-validated so it can be reused at the subsystem level, and that again reused at the system level, moved across simulation, emulation, FPGA, post-silicon. Now I'm parroting straight EDA ideas, right? And the best way to do that is have the representation in something that can be synthesized to UVM, to the subsystem, to the full chip, to simulation, emulation, post-silicon. And that's why this idea makes sense, right? It isn't about can AI generate UVM. It's about what is the most useful thing to create, where from a single source of truth, we can prove that things work at all levels.
True, but I get Shelley's point, which is if you want to promote adoption of AI methods, you take the shortest path, wherever that shortest path is.
I mean, I think we all have the problem that we've got to show incremental value, right? So if we ended up with UVM sequences, let's say we can do it 10 times faster, but it requires 3 times the review, whatever. We end up 2x better. Better than not having anything. But if you get it in one go, solve the stack. Solve the stack, you're that much further ahead.
Right. Okay, so we're at 7:28. I want to make time for questions, so let's move on to the question starts with, I mean, all of this is fine, but there is a human element to trust. So how do you help DV engineers and their managers develop confidence in these methods? I mean, you can run something once and it works. Okay, it ran once. But you run it again, I think that was the point was made earlier, and it gives you a different answer. So how do you build that confidence? And particularly, how do you build the human element of that confidence?
Don't we have that problem even right now? Every DV engineer is different. So if you give the same problem to different DV engineers, they would solve the problem very differently. How do we solve that right now?
But we know how to deal with people. At least we think we do. So, AI is still an unknown person. You want to look at it that way. And you make a fair point, Shelley, but I think we need to understand how to do that.
I'm going to argue that this is something that will move us forward. Okay? Everybody in this room has been a DV engineer sometime, or else you're lost in the wrong room. All of you know that the chip industry works because of us. Like, we are trusted to go verify some piece of this design, and nobody but us really understand the ins and outs of that functionality. We are the ones who did it with force of will, right? And we became important because of that, and this is how it worked. Why wasn't there people who could judge whether our test plans were good? Why weren't there people who could judge whether the test we wrote from those test plans are good? We only graded on, did we check the lines in the Excel spreadsheet, coverage, and how many bugs we find, right? So I think this gives an opportunity to start developing ideas like, how do you grade how good a test plan is? How do you grade how good a set of test cases that in a test plan? We've never had time to solve these problems, and now perhaps we are forced to.
Good point. Fine.
I think it comes back to trust but verify. It's get the data, and the human needs to go and review it in order to be able to figure out, yeah, the AI did the right thing, or no, it just total crap.
So does that put an automatic kind of time constant on how quickly we get up that curve?
Not necessarily. I think it makes us think a lot harder, but what are the right questions to ask become more and more important, right? Today, we don't have time to have 2 engineers write the same test plan and cross against each other. We don't have time to go line by line through each test case, so we have to trust the engineers. Well, Now, if some machine is doing it, it can afford, I mean, this point is already brought out, right? It's not my point. Go have 3 different engines do the same thing and then cross-correlate against each other. Have 3 of them go build the answer, have 3 others go figure out what is a good test suite for that answer, see if it comes out right. Or better still, have a 3rd group go come up with a coverage model for this answer. How do you do a coverage model for how good a specification is? I don't know, but we figured this out.
But I think the other part is trust but verify. When we look at the test plan, that's the start of all evil. Well, everything that we do is based off of that test plan. And something that we tend to think of an AI solution as it's just going to spit out something and then we take it and we do work with it. I don't like that idea because I don't see how that model of just taking a result and then using it is something that we can verify. When I go when I'm looking at a test plan, I'm looking at AI suggestions for the test cases and the test plan itself alongside the spec. So I can actually verify as I look through and do my own reading of the spec itself. So I think a lot of focus needs to be also made on how do we present the data, how do we present the results in a form that is consumable by a human more easily.
And would you add to that you're kind of implying that you're doing a design review on what the AI tool is presenting to you at that point?
Yeah, exactly. Yes. And it's probably going to be right more times than not, but where it's wrong, I have the opportunity to say, hey, you've given me a test case that specifies, that goes along with this particular line in the spec. Well, that line didn't have anything to do with the test case that you came up with, so that's wrong. So I have a much more immediate feedback loop in order to be able to weed out the crap from the good stuff.
And let's take what Mike's saying and make it like viscerally obvious to everybody in this room. What if the question was, hey, AI, go read my 600-page DDR spec and just generate for me a flowchart for the primary use models for this memory controller? Is this obviously a good idea? Yeah. You look at it, say, do I agree, do I not agree? Yeah, you're missing this. Oh, we've thought of this flow that I wouldn't have thought of.
So you treat it as a very junior engineer and just check through point by point.
Let me contradict that. Let me suggest that when we're working as hardcore DB engineers, the best of the best, we're reading the spec, we're somehow putting that flow chart in our head, but we never take the time to write it down. Right? So this wasn't about making it a junior guy, it was about decomposing big problems into baby steps that are reviewable. That was after Mike's point of intermediate representations that can be understood. Right? That's kind of my current shtick on this. Because we're doing 3 things with AI, right? We are trying to work with folks who are the hardcore AI companies, and we want to be their back end, right? Sooner or later, the MCP will be set in the middle of all of this, right? Second is us trying to use AI internally, trying to get these big giant specs read and understood. And then the third is, yeah, we need this to work because we're verifying a whole boatload of AI chips.
DVCon.
Yeah. I'm actually, I want to really second what Michael said, but that just brought an idea. The thing is, I think we need to also have a critiquing AI agent. So even if you're going to use an AI output, we need to also use another agent who can act as a reviewer in order to review, critique, and give feedback and constantly. I think that might help increase the problem that I also see is today. Earlier, folks used to say that okay, your project deadline is, let's say, in 6 months. Earlier, they used to say, do you want more resources? But more than once I've seen my execs come and ask me, can you use AI to really get this done quicker? I can see that trend, in play, right?
Mm-hmm.
And so I think because again, the reason is there is a lot of investments, being made with respect to AI. So now, as a result of which, they need to turn to this typical. And then they also want to see tangible value. The tangible value needs to be would be in terms of time, productivity, and the number of people needed to do the job. Right. So all of these things are going to be input. So that is where I have a slightly different perspective. I'm coming from old school of trust, verify. We may not be able to verify that by using people because we will not get time.
Interesting.
That's
Very interesting.
That's the perspective. So we still have to rely on agents to, do that. And in fact, this is something which was very interesting that came up on Harvard Business School. I think, for 2 weeks, right? Like most of the execs, before they go into a very high stake interaction, earlier they used to train by doing analysis. These days, they used to AI agents to talk to each other for and against. They pick a lot of learning from that and they then go to the boardroom, right? So that is exactly how the world is really. So I'm just trying to see how we can.
Yeah, that's a very interesting point.
Yeah.
Shelley, so we're on the topic of building human trust, or if we even have time to build human trust.
That I completely agree with you, Buck. It's a very interesting observation. So far, we had different kinds of systems in place for cross-checking, right? Like we have test plan reviews, we have code reviews, we have code coverage, we have functional coverage. These are all checks to make sure that every engineer is doing the job. As Deepak is saying, like these things also takes time. So this cannot be human anymore. This has to be an AI as well. So when you have the real job done by AI and verification also on the cross-check also done by AI, then we get a good system which we can cross-trust.
But then without the humans in the loop, how do we trust the attempts, right? The multi-LLMs, how do we trust the judge or the critique that comes back? That's a question that gets to another question, right?
Praise God in the gods.
Yeah.
But I think that becomes the question. I think we're all sort of ultimately hinting at that, right? That how do you decompose the problem? How do you make sure that each state is verifiable? How do you, I mean, your point, Shelley, on coverage and test plan reviews, I mean, this may be also what I was saying in a different way, right? Which is now that the test plan might be built quickly and the test cases might be built quickly, we have to put a lot more effort into who is the reviewer, how is it reviewed. And to me, Mike's point about intermediate representations that are readable, I think becomes mandatory. It's some machine spitting out code that nobody can read, that some other machine is reading, we're lost, right? I mean, let's say every stage has, pick a number, right? An error rate of, is it, 1 in 20, 10 to the -1, 10 to the -3, don't care, right? They'll multiply across basis, right? None of us think it's going to gain to 0, right? So.
Okay, good. So very interesting point, Deepak. I don't know how we struggle with that one.
And I'm reminded of the conversation we had earlier, Bernard. So verification engineering might become obsolete. People might become verification scientists.
Yeah, I have to credit Avi at Siemens for this one. He came up with this term. I think it's a very good term. That verifiers start becoming much more like kind of like data scientists in the AI world, where they are considering the kind of the higher level view of what they're doing rather than the low level mechanics.
Yeah.
Very nice idea. Okay, so one last question, and then we'll turn it over to Q&A. So I know that this preys on at least some minds in DV. Will DV engineers be training their AI replacements? And how will all this AI improve the lot of DV engineers? Are we gonna train all of the AI and then we're all out of a job? Or are we improving our jobs somehow? So comments.
Did you just fire me and everybody else in this room?
Yes. Well, no, I told you to, now you've got to defend your job.
Defend my job.
At least until you retire.
I don't think anyone in this room or any verification engineer need to be worried at all. Everyone is going to have their jobs and more. There is going to be a lot more things to do. Everyone will be super productive and we will be building more and more and more chips. The reason why I say that is like, when I was at Microsoft, right? So we had a team, one team that could build a chip in 2 years. But there were so many requirements coming from different sources, like to add in so many different features. But all we could do was one chip. It is limited by the productivity of the team. Now, if the same team can build 5 chips, they will happily take it. They would build 5 chips, no questions there. So it's right now, we are so limited on the productivity on semiconductor engineering because of the number of people that we have and productivity of people that we have. I think we are all safe, should be fine. We are all going to be super productive in the next couple years.
I have a slightly different opinion.
He's the manager.
Which is actually.
Well, you're gonna go,
I'm with you. I think, the number of people or number of engineers needed to do the job, make a chip is good. Should absolutely. I think there will be a very hard requirement that if you are investing 100 people to do a chip, it has to be with probably 40%, right? That's one thing which is already in the works. And then the other thing which I firmly believe, if you are curious, if you can ask good questions, if you have a learning mindset, I think AI will be a spectacular companion and that would really make you extremely productive and be in, always in demand. That's my firm belief because if you're very stuck to your old habits and then I think creative destruction will happen and you will be restricted as part of the thing. That's what I really think.
bold position, good.
I've told my kids, don't do what I do. Because your job, that job will not be there when they go into the industry. Right? Our jobs are gonna evolve.
Yeah.
And the grad for today is gonna have to have a very steep barrier of entry. They're gonna have to essentially become an architect because they need to be able to be smarter than the AI system or smart enough to help direct the AI system. And that's a completely different skill set that they're gonna learn.
I think that's a reliable statement. Our jobs will evolve, right? Every time new tech has come out, jobs have evolved. And I also put forward the idea that maybe anybody who is doing DV and semiconductors, we're by definition doing something that has not been done before. It is not like an outfit that is out building websites, right? We build, I don't know how many websites they have in the world, but it's got to be something in the billions. It's different data, but same tech over and over again, right? That's not our world. Somebody's got to fill in that new information, right? Someone's got to, even if they're constantly training. I think you're right, but I think the jobs do change. I think maybe you do become DV scientists. I'm not quite sure what the difference is between a scientist and an engineer, but anyway. Oh, really? I changed
So I want to allow some time for questions. You have to, we put this over there.
I'm gonna try and do that.
So, any, geez, can we get that in there? Any questions? That's it? Oh, is it turned off?
No, it's fine.
Definitely on.
Yeah, there we go. Okay, any questions? We've got an entertaining group here, so I'm sure they'll find entertaining answers to whatever question you ask.
Good, we can line.
I'll start.
Okay.
I have a couple, but we'll start with just one. You guys mentioned specifications being incomplete. It seems like one of the best tools we could probably have as a DV engineer is something that makes the spec better, something that will transform it from just whatever the designer thought about into something that a test plan can come out of. Like, I've looked at IEEE specs and they have like shell and must and pepper everywhere. And it's perfect because you look and you see this is what it's got to do. So maybe the AI could qualify the spec for DV, could ask the engineers questions. They could fold them in, could find the holes in the spec so they could fill them in before DV ever starts. So that would be a tool I'd like to see happen.
I don't want to steal that thunder. That is going to be our next tool coming on called spec agency.
I assume that. Is that even possible? Because sometimes from what I hear, the spec is by definition in flight.
It's okay. It could be in flight faster and better.
Okay.
It could come to 95% much earlier than it does now.
This is a topic near and dear to my heart, okay, so you're gonna get an earful from me. First is, how many specs have you guys read where you're looking at it for the first 2 hours going, okay, got it, you told me about 1,000 registers, but what the heck does this thing even do? Could I just have the executive summary of purpose, gazettas, and gazettas, right? So that, I think, is a good candidate for an AI to go pull off.
That's not enough for DV though.
It's not enough, but I'm talking to you about when you're entering a project, before you got there, right? You read this thing going, what are you talking to me about, right? So this is what. Second, my point about pulling a flowchart out, right? This is no light point in the sense that what are the big use cases for my device? And why am I attached to it? Because that ends up being a very nice input from which to feed test synthesis, right? So what is PSS after all? It's just simply a way to describe flowcharts. So, and then you can start drilling into what is each box in the flowchart and so on. So better specs, independent of AI, is a big problem in the industry. And maybe AI can help. Maybe people can say the name and where they're, what company they're from.
Yeah.
It's easy.
My name is Chandra. I'm from Intel. My question is, okay, so you guys rightly said that, okay, AI is currently used as a companion, right? Okay. So is there a time that comes later point of time where we can say the test bench that they use for us, right, as a verification engineers, can we trust that for a sign-off, right? Can we really trust that for a full chip as a test bench sign-off, right? It's a verification sign-off. Can we really do that? Do you see a timeline of it?
Yes, I would like to break that question into two parts, right? One is first generation development and a derivative chip, right? Now let's say you're doing a derivative chip where you have one chip and you're kind of changing few features. And ideally, even for that, in any company, right, I mean, almost all companies, they would say 40% of resources are needed to really do the qualification and things like that. That I really think is doable. Probably just given the concern, it's not going to become 0%, probably from 40% it might come down to 20%. And once we start seeing results, it will further come down. That is what I really see. And that, at least in my hunch, is another 2 years. Just my
Optimist.
Okay.
I will say that would be risky for our jobs.
I think their ability to get to sign off will come. I mean, it has to be the topics that we've been discussing, right? That can we get the critique agents in there? Can we find a way to get these stages to self-check to our satisfaction? Can we get the intermediate results after in a format that we can make sense of?
Can we monitor?
Exactly.
Honestly, how you get there doesn't, to me, it doesn't matter. It's just whether you have the right data to say, yeah, I'm good. Because how you got that data, whether it was a computer or whether it was a human punching all the numbers, that data is not something that your manager is going to know or think about. They're just going to say, did you give me the right data for me to make that decision?
And let me give you the strong argument against, right? I mean, since we've all said yes. Okay. So we're in the business of test generation. And I can't tell you how many times managers have asked me, why don't you just read my RTL and generate all the tests I need? Which is a tautological question, right? Because if I were able to do that, and any test ever failed, it's my tool's problem, and it is with zero value, right?
This is Bhaskar from Intel. I'm an IP design and design verification. So my question is one, I've been using for past 1 year, my productivity has increased. So one of the question is, we started using everything, but I feel how data is getting protected because we are more into, okay, how can I do this? But underlying how it does, how the data is saved. So as a community, are we, like, how is that to be considered? So basically, we are training the LLMs. Are we training the LLMs or is it already known knowledge? So
Are you
that
worried about whether it leaks out?
yes. So that is something like, I mean, as a verification, I have a, like, is there some standard protocol someone is looking? I know each company has their own set of, but I know that there is a security aspects as well, right? Is it leaking? Is my data is safe or is it going out? So is there anything industry is thinking that standpoint of view?
It is already there. Actually, the thing is, LLMs, okay, it's trained on publicly available data. And then, let's say, whenever we are using AI, it could be individual or a team, you have an API key that's associated with that particular person or the team. And outside that particular enclave, there will be no leakage. And that we have to again trust the company, right? Is as much as using any search engines, like even now, probably we know that our phones are listening to us, right? So those things are always there. But yeah, that's how it actually operates.
Yeah, and it's absolutely true. There's one more thing to that. So far, we consider every piece of IP very, very valuable because the cost of developing that IP is like very, very high. Because your engineers worked on it for so many months or years to develop that IP. So going forward, that cost is going to come down. So how valuable the IP is or how much instead you want to secure that IP will actually come down. The whole thinking process will change. That's my thought.
So the second question I have is on the test plans. I see if there is N-1 generation and we are doing something, adding that one, I think it doesn't do a good job. Because does not do. Because we as a humans, we know what is the N-1 happened and all the data. But when we try to ask, I think it just has it as a limit. So that's so.
This is because the spec says this works just like N-1 except.
Yeah, you refer to so. Yeah,
This is my favorite. Offline, I won't know what to use.
That is kind of true because for us, even when we developed our platform, for us it was much easier to start everything from scratch rather than use an existing test bench or design and develop on top of it. Mainly because we have no idea what the structure of the test benches, what the folder structures are. So we cannot do it. Guide AI to do it in a very organized fashion. So that's true. That's at least our experience. It's been more challenging to bring design. But the things are getting much more efficient these days. So my answer would have had a lot more value 5 or 6 months back. But today, I think it's going in the other direction. It's going more towards what people were saying.
thank you.
Anyone else want to take a jab at the
I get that stuff.
concept?
My name is Matt. I work at Cerebral Systems. I do hardware for AI. The question is, Anand alluded to a little bit, and that's where should the firewall be between what the AI sees to generate stuff? Like you mentioned, should the AI generate tests from the RTL? And I've seen some tool companies pitch that kind of thing. but because it'll generate, look at the RTL, it'll find something wrong, it'll generate a test that validates the wrong thing, and everything moves on. So where do you think you think it's going to be good enough where you can trust it to do that? Or should there be a firewall between, like, one AI does the test plan development and the other AI does some kind of RTL comparison to the spec and whatnot? So where do you guys think the line should be between where you let AI?
My 2 cents. We still don't trust humans to do that. So why would we trust AI to do that?
It is a DV principle, though. Don't look at the RTL
Yeah.
if you can help it.
Yeah, that's a very good point. So in general, we don't want to look at the RTL to generate test plan at all. But in my experience, at least, there are certain cases where you do want to look at RTL. Say there's a FIFO. I want to make sure that the FIFO full condition, the FIFO empty, overflow conditions are met. So how do I create a test case? That's very implementation specific. It's not mentioned in the architecture spec. Right? So it's a choice of the designer. How do you make sure that those choices might expose corner cases, that we are testing those corner cases? Yes, in general, we have to be very, very careful not to, or when we look at the RTO, it has to be very intentional and very specific to these kinds of cases.
I think it's a very interesting question, Matt, and I hadn't given thought to it, but my generalization of the answer would be send one agent to look at the spec and write the dev RTL, send another agent off to look at the spec and write the test plan of the test, not looking at the RTL.
It can be the
Just have
same
the two
agent.
duke it out.
It can be the same agent if you delete the context.
Yeah, we're saying the same thing. Yeah. In fact, Shelley, why aren't you doing the design as well?
It's on the way.
You guys laugh at me, but I've been in the shtick of this test of this for a long time using these graph-based models. And it's been more than once that we've been asked, well, if the graph-based model describes the entire intent of the system, why can't you just generate the logic from it too?
One of my guys was sitting through the chip agent's lunch, said, why don't they just generate the RTL correct from the beginning?
Wouldn't need these damn DV engineers anymore.
It's the risk of $40 million worth of NRE is what it is.
But see, they've got so much cheaper. I just let Shelley said it.
So here's the thing. It's not so much of a question, it's more of a discussion.
Oh.
So here's the thing. Specs are not always a thing. We're in a startup company. We do have specs. We have the RVA 23 spec, right? We're doing a RISC-V. My name's Doug Good. I work at Convo Computing. So we're doing an RVA 23 RISC-V board. So Adnan knows that very well. Shelley knows that very well.
It is.
Yeah, exactly. So that's the best spec we have. The stuff that our engineers do is largely ad hoc. And I don't know about many of you guys in here. I can't imagine. I've been in this business. You can see all the gray hair. I've been in this business since I started in engineering.
Why?
Never do I get good specs. Even when I worked at Intel. There might be a spec at Intel. In fact, Intel is better than anybody else. But even then, we're still working ad hoc with specs. So that's why Shelley has a thing that takes your spec and turns it into stuff. We're trying to figure that out. So the comment is, we have to work, like I said, ad hoc to figure out how to make AI fit into a world where you don't have perfect specs. And what you said was perfect. The verification engineer has to make sure the design matches the intent, not necessarily the spec. So that was just my comment that I was thinking about.
It's very interesting that you said that. Probably we should move to the higher level of abstraction. Sit here and say, I need this product. AI build it for me.
I think that's honestly, so we all can go and do something else.
That's kind of where it's going to go.
Yeah.
please build me silicon that'll give me 80% market share.
Yeah.
Enough said. But nobody's going to take on Doug's question. I mean, we've been sort of bouncing on it a little bit, I feel. My thing about give me a table of opcodes, right? It was really for this problem that where, to me, the 95% accuracy was a whole lot worse than 80% accuracy because I almost trusted it and then got nailed by the ones that weren't there because we forgot them. Okay. Read spec, turn out a transition table for me, right? These kinds of things, I think these are very real baby steps. That was another way of saying pull out a flowchart, right? Transition tables, flowcharts, that was all roughly the same thing. But this idea of trying to tease it to bring out what is the big picture story before going after the little picture story, right? Decompose it for. This is how you teach a new engineer as well. So we sort of know these things. We never had the time to do them before. We relied on good engineers being self-starters. Well, now those good engineers are automated, but we have to get a whole lot better at teaching them.
That's a good point too. And that's what we're doing.
Yeah.
But this
Yeah, but
is,
theoretically, we have the time now too, right?
this is my point. This is my point, that now we have 100 new brains running around and we take the time.
Until Big Facts Block realizes that we're saving that much time and shortens the schedule, right?
So, what, adding more design?
No, and I kid you not, right? We're doing this at Breker. We're building up a team of young engineers in some third world country. They don't know anything, and now we're going to figure out how to train them and how to give them tasks that they can manage, right? These are human beings, but it's the same old problem.
This has been my experience, right? So you start with the spec, the architect throws a spec at you. It's like probably 70% complete, probably 30% complete, don't know. And then the design team and the verification team are asked to like, okay, start up, it's 70% done. So they look at the spec, they have no idea what the hell is going on. So they start asking questions, pick up the phone, call them, or ask for a review meeting, or send emails, so send IMs. They go back and forth and back and forth. Eventually, everyone gets to know what's going on. Eventually it will happen. Then they go up and start doing their design work and their verification work. And the poor spec is still sitting there at 70%.
It's all communal knowledge.
Yeah.
Historical knowledge, yes.
So that is the problem we are trying to solve. Instead of everyone going and asking the architect to explain the spec, what if an AI agent is talking to the architect and asking the exact same questions that the design engineer or the verification engineer would answer and keep getting the answers? And on the right-hand side, you get a green spec that the design team was evaluating.
So the tempting thing that I'm seeing is you now have RTL that does what that 70% said and then some. So you take that RTL and you say, hey, wait, we've got RTL, let's generate a spec from that. Well, then, are we going to verify that? Or are we verifying to the intent that Adnan said? That's really what it is. Intent.